This video will take you through all the examples in your notes that I did not do in the previous two videos about the theorems. So feel free to fast forward, find the example you're looking for, and watch just that one and do the best you can to answer these questions. So here we go with example number 1. You can see I've already marked the given information on the picture. We've got the measure of angle TNR is 135, the measure of arc TR is 140, and the measure of arc RQ is 30 degrees. So what I'm looking for here first is this SQ, which is the intercepted arc from point S all the way to point Q. So if this is my variable x, I'm going to use the chord-chord theorem that says a chord-chord angle, which in this case is the 135, should equal half the sum of the intercepted arc and the arc of its vertical angle. So I'm going to mark its vertical angle here as well. What I notice is that SQ is the intercepted arc of that 135 degree angle's vertical angle. So that means this 140 degree arc plus the intercepted arc of x, SQ, that I'm looking for, divided by 2 should equal this 135 degree chord-chord angle inside the circle. So I've got a little bit of algebra to do. First thing I'm going to do is multiply both sides by 2, which is going to end up giving me 270 equals 140 plus that unknown arc. So when I subtract the 140, I end up getting that that unknown arc of SQ is equal to 130 degrees. So arc SQ measuring 130 degrees. Now I'm looking for arc TS. So let me clear up the picture a little bit. This is why I never do this in pen. I always do this in pencil. Arc TS is this arc right here. I still know this is 140. I still know this is 30. And now I know that this other arc is 130. Well, I know 3 out of the 4 arcs on this circle. So I'm simply going to add those 3 arcs up that I know. 140 plus the 30 plus 130 is going to give me a total of 160 to 300. So that only leaves me 60 degrees left over out of the 360 for arc TS. And then the measure of angle TSR. Again, I like to trace these out. So angle T to S to R would be this angle right here. Well, that angle is intercepting arc T to R, which is 140. So I got to remember, keep it straight. If the angle is on the circle, it's half. If the angle is inside the circle, it's half the sum. And if it's outside the circle, it's half the difference, or subtracting. So since this one is on the circle, all I need is 1/2 of that 140 degree intercepted arc, which in this case would be 70 degrees. Next example, again, let's put our information onto the circle. It says that arc AB is 100 degrees. It says that arc AD is 80 degrees. And we have arc DC is 84 degrees. And we're looking for all these other angles. So we're looking for angle ACB. Again, let's trace that out. ACB. Well, that angle is on the circle. So that angle is going to be half of the intercepted arc, which I can see the intercepted arc is between A and B. So that's going to be half of the 100 degrees, which in this case is 50. And then I like to erase all that and start over and find my next part. The next angle I'm looking for is BCF. So I trace that out. BCF. This angle again is on the circle. So it's going to be half of the intercepted arc. The problem is I don't know what this arc is over here from B to C that this angle is intercepting. But I do know 3 out of the 4. So again, I'm going to add these together. I get 100 plus the 80 plus the 84, which gives me a total of 264 degrees. 360 degrees for the total circle minus that 264 is going to leave me 96 degrees. So this intercepted arc over here is 96 degrees. From that, I'm looking for angle BCF, which should be half of that 96. So half of that 96 is going to be a 48 degree angle. Angle BEC, again, I'll leave the 96 because I figured that out, but erase everything else. Angle BEC, so from B to E to C. Now this is a chord angle, or in other words, it's inside the circle. So this angle has a vertical angle, and the two intercepted arcs that I'm looking for would be between B and C and A and D. So my job is to find the sum of those two intercepted arcs. So it's going to be 80 degrees plus the 96 degrees divided by 2. So what I'm getting is 176 degrees divided by 2, which, if I'm not mistaken, would be, let's see, that goes in 88 degrees. Double check my math. I'm doing this without a calculator. All right, the next one. Again, I like to get rid of those things that I've marked, everything except the angle that I highlighted. So now I'm looking for the measure of angle ACG. So A to C to G. This one again is on the circle. So when it's on the circle, it should only be half of the intercepted arc. This one, however, actually intercepts more than one arc. It goes from A all the way around to C. So there are two pieces of arc there. There's 80 and 84, which is a total of 164. So that means that this angle ACG should be the entire 164 divided by 2, which is an 82 degree arc.